So I guess I'll send out an email as soon as that happens, because that has a majority of the course content in it in terms of homework assignments and things like that. But what I'll be talking about during our class lectures is kind of the highlight reel of that stuff. So today, what I want to do is I want to kind of do a background on computer networks. Now, some of you, in fact, actually, let's do this just so I can have a bead on my audience. Let's go through and just have everybody introduce themselves, tell me where you're from, and tell me what kind of classes you've had on computer networks before. So I kind of know who my audience is. So I'm just going to go in the order of participants. One of your names is going to be your phone number. So let's start with Asif Ali.
Hi, I'm Asif. I'm from India, and I have done
Which part of India?
courses on network security. Hyderabad,
Okay.
Telangana.
And what network stuff have you had?
Yeah, I have done network security course.
Okay. Yeah, I was in Hyderabad, what I guess like 2 years ago, 3 years ago, something like that. You can only have biryani so often before you get sick of it.
It's good to hear from you, sir.
Yeah, good to hear.
Okay, so let's go to was it Kashef Ahmed?
Yeah, sir. Yeah. Hi, sir. This is Kashyap. I have done my bachelor's in computer science, and with the background of C program and networking course. And in 2017, I did. After that, I got campus in the TCS. So it's been 4 years ago. So after that, I have been choose to learn more and to pursue my master's in same course, same background, computer science.
And where are you from?
I'm from India, from Hyderabad, same state, Telangana.
Yep. Gotcha. All right, and let's go with our phone number, 568-052. Who are we dealing with there? Here, I'll ask them to unmute in case they don't realize they're the ones I'm calling on. Not getting anything. All right. Well, we'll come back to. So let's do Rizwan.
Hi, this is Rizwan. I'm from India, same Hyderabad. I have done my graduation in electronics engineering, and I've been working for 3 years for Amazon. So I got an opportunity to study here. So I'm glad to study under your guidance, as networking is one of my favorite subjects.
What have you been doing for Amazon?
Working for supply chain management in IT.
Okay. Let's see. Let's do Sumit.
Yeah, hi sir, I'm Sumit and I'm from India, Andhra Pradesh, Vijayawada. I have done my bachelor's in mechanical engineering.
Okay. Any networking background or mostly engineering stuff?
No sir, I know only the basics of the C language, that's it.
Okay. Let's see. Shakar. See, now we see who didn't, who just has their camera off and is off in the other room doing something else. So we have the foo number and Shakar so far, not in front of their computer. Okay, let's keep, we'll come back to them. Swadeep. Nothing there.
Hello. Yeah. Yeah. Hi, sir. This is Pradeep.
Yep, go ahead.
Yeah, I'm from India, Hyderabad, Telangana state. So, like, I have done my bachelor's from electronics and communication engineering. So, I have a basic on computer networks language. So, I have done. So, after my bachelor's, I am into the software industry. So, I was working for Packard Solutions, which deals in delivering applications, software applications.
Okay. Let's see. Rama. No takers for Rama.
Hello. Good morning, sir.
I can hear you.
Yeah, I'm from India and the southern part of India, Hyderabad, and I have done my master's from UK on 2020, passed out in 2020.
And what was the master's in?
It's computer science, and I have studied about computer networking and operating systems like stuff.
Okay, so you're doing a second master's for student visa purposes?
Yes, sir.
Gotcha.
Thank you.
Okay. My participants keep changing order on my list. So let's see, we did. Here, we'll try our foo number again. People are still popping in too. We did Ali, Rama, we did Kashef, we did Rizwan.
Yes, sir. Yes, sir.
All right, go ahead. So where are you from, and what's your networking background?
Sir, you are asking for me?
Yep, go ahead.
Yeah, I have already informed, but still I do. I'm from India, the same state, Telangana. And my background, I have done my bachelor's in computer science in 2017 with the subjects as C language and Java with the basics. So, and in 2017, I have completed it. After that, I have I have got campus in TCS working as a banking domain operations. So now I got the opportunity to learn masters in Concordia under your experience.
Okay, so let's see who's next. Let's do, is it Al? Hekriat?
Hi, my name is Dikrayat Al Ashur. I am from Saudi Arabia. I studied a diploma in computer science, more in programming than IT. I studied a bachelor degree in health science, but I back again to study IT because I'm I'm volunteer to handle websites and do a lot of IT for them.
Okay. Let's see. We have Mohammed Zain.
Hi, my name is Mohammad Zain. I've done my bachelor's in computer science engineering recently in 2021. While studying, I used to work as a UI UX designer at A2Z Solutions.
And where are you from?
India, Hyderabad, same state.
Yep, gotcha. I expect many of you, not most of you, but many of you to be from Hyderabad. That tends to be an area that we pull a lot of students from, but still good to hear about it.
Yeah.
Yeah, that was a very interesting trip when I went to I've never seen traffic like I've seen in Hyderabad. I don't think I would have been able to drive there on my own.
Yeah.
I had a driver that took me everywhere. It was insane. You guys have like a language of honks. People honk certain ways and you know what they mean. So I don't know. I thought that was kind of fascinating. Let's see. And Sandeep, Kali. Got nothing? Nothing from Sandeep? All right, so one last time, we'll try our phone number. I'm guessing they're on maybe a cell phone. They don't have, well, maybe not a cell phone because they don't have a camera, but that's fine. But they have a microphone. Phone number 568-052. You're logged in as guest. One thing that you'll, if you log in with your CUW number, then you won't have to have me admit you to the room. It's not the end of the world if I have to admit you to the room, but just FYI. All right, so our phone number is
Hello.
oh, is this our phone number? What do we got?
Yeah.
Oh yeah, there's our phone number. Go ahead. Introduce yourself. Let's get your name first, where you're from, and your background in computer networking.
Yeah, I'm actually from Andhra Pradesh, India. My name is Ganesh. I'm from computer science engineering, and I have been working in Wipro from past 2.5 years as a Jora analyst. At the start, I worked as a .NET developer.
Okay. Let's see, anybody else that we all right, one last try on Sandeep. Oh, Sandeep doesn't even have a microphone. He's got a camera though. Oh no, he doesn't. He doesn't have a camera. It sounds like he didn't join computer audio. So he might not even see me. Actually, he does have video, but just no audio. Okay, Sandeep's got some network issues. All right, so we'll work those out, but that gives me a bead on anybody else here that I missed. My order kept changing. So did I hit everybody, or did I skip somebody.
I think no, sir. Only the one which the guy has having network issue. He messaged in the box. Only one
Okay.
we missed.
Yep. Okay. Gotcha.
Yeah.
All right. So let's start talking about stuff. It seems like many of you do have a network background. One thing that I try to do is I try to start my classes off with some preliminary information, because not everybody who comes to grad school, and this isn't just a situation in computer science or folks coming from overseas or something like that. It's pretty common for folks with who have bachelor's degrees in one thing to go and do a master's in something else. So that is a hold on, let me reply to them because I don't think they can hear me. All right. So it's not uncommon to have somebody who comes in with a background in something else and is playing catch up when they do their master's degree in computer science. Now, having said that, I am going to make the assumption that you have a education maturity. You know how to study, you know how to learn things, stuff like that, that you're going to be able to pick up stuff relatively quickly, and things that you don't know, you'll go and research on your own and find out, and then ask questions if you have questions. So keep in mind that it's not going to be a valid excuse for you to say, oh, I've never done X, Y, and Z. My expectation will be that there's something I didn't cover in class, and you haven't had it before, that I assume that you either have a background in it or have the capability of going and researching it yourself, and that'll be on you to spend the time to do that. So just keep that in mind when you are either doing a homework assignment or expected to know something. If you don't already know it, doesn't matter whether you should know it already or not, go and research it. Okay, on a similar note, when it comes to submitting your homework, the hope would be that everybody will be able to submit it with Blackboard, but I know a couple of people were getting our kind of last minute visa stuff in order. So if there's assignments and you don't have access to Blackboard yet, and right now none of you have access to Blackboard because the course is still closed, they haven't copied the material over to it yet. I have an email in, hopefully that pops up today. But if you do not have access to Blackboard as we get into the assignments, email me your assignment for now so I can at least grade it and record it in the Blackboard gradebook until you are able to have access. Let's see. So as far as homework assignments go, kind of an important thing, and I think this does end up being somewhat of a cultural thing. So let's get it out of the way right off the bat. You know, when you submit homework, I want to make sure that it's your own work. Now, having said that, I don't mind if you and other classmates collaborate on homework assignments and work together to help you understand the material better and things like that. But what you submit as your homework assignment should be your own work, okay? Not somebody else's work with the name changed, and certainly not like if it's a paper, certainly not you going through and copying something either off another student or off the internet and going through with the automatic thesaurus thing and changing words to alternate, you know, to other words that mean the same thing. That's pretty obvious to a professor when you do that. We have tools that check that stuff, and it kind of ticks us off when we see you blatantly trying to deceive us. So, you know, look, I get paid either way. You're all adults, but do your own work and submit it. And, you know, education should be fun. You know, I do realize that specifically for international students, there are some hardships that you run into when you come to the United States. You have, you know, housing issues, you have, you have to pay bills one way or another, and you have some limitations on where you're allowed to work and things like that. So you do have some other priorities, perhaps outside of studies. And I can respect that, but keep in mind that those are your problems. So from a classroom perspective, I'm going to expect everybody to do their own work, and that kind of stuff. I have I'm pretty close with some of our former grad students, specifically folks from India. So I kind of know the inside scoop of what life is like, and also what some students will do to get their homework assignments turned in. So assume that I know all the tricks when you go and try to circumvent the process. All right. So at the end of the day, homework assignments, I expect those to be your own work. You're allowed to work with other students to help you learn, but what you submit should be your own work. All right, we're good with that? All right. So let's talk a little bit about data. All right, so at the end of the day, when we're dealing with computers, all of our data will ultimately be represented as zeros and ones, right? Okay, and those zeros and ones have ultimate meaning depending on how the data is encoded. So if we, for example, have a text document that is encoded in Unicode, let's say, that means every collection of 16 zeros and ones will be representative of a single character in the Unicode character set. Let me throw a slide up here. Can anybody tell me the difference between Unicode and ASCII? Or tell me something about either one of these that you know of? Just anybody, just start blurting it out. I am fluent in Telugu, so you can speak Telugu if you want to, but your other classmates might not be. Got nothing? All right. For audience participation. All right, so we have, these are character sets that represent a table of mappings between a character and a number. Let me kind of show you. Bring up the ASCII character set here. So, for example, if we go to the letters of the alphabet here, here's an uppercase A is decimal number 65. All right, and we'll look at how that ultimately becomes a binary number here in a minute. Okay, but effectively, when we deal with numbers, so see here for the character A, it's a 65 in decimal, it's a 41 in hexadecimal, it's a 101 in octal. So octal is a base 8 number, hexadecimal is a base 16 number, decimal is a base 10 number. But the point is that these three numbers, 65, 41, and 101, are all the same number. They all mean the same thing. They're just in a different language. This first one, 65, is in the language of decimal numbers, the language of base 10 numbers. 41 here is in the language of base 16 numbers. This one is in the language of the base 2 numbers, binary. Okay, but they're all the same value. Computers prefer the binary numbers because they are decimal or they're digital pieces of equipment, on and off, representing things in zeros and ones, on and off signals is kind of in their wheelhouse. All right. But understand from a human being perspective, these are all the same value. They're just said in different ways. Okay. Very similarly to how many of us in this room speak some different languages. I could make a pretty good guess at some of the language I already said. Telugu. We probably have a couple of Tamil speakers. I'm sure Urdu is represented in here, so on and so forth. All right, but bottom line is you take those different languages and you have words that mean the same thing, but they're still different words. All right, it's pretty similar to what we're dealing with here. Okay, so this is the Ascii table. Okay, so the Ascii table has 128 characters in it, and there's extended Ascii that gets us up to 256 unique characters. All right, so what this is a table that maps between those 256 characters and a bunch of numbers. Because when a computer stores a character, okay, again, getting back to what we were dealing with here, data. When a computer is storing data or transmitting data over a network, when it's dealing with data, it's going to store it as a bunch of zeros and ones. And depending on the nature of that data, those zeros and ones are encoded in a certain way that then need to be decoded on the other end in order to get meaning. So in our simple example here, if we are sending a text document over the internet, let's say, and that document, if we were to look at it at the digital level, would be a bunch of zeros and ones. And let's say we knew it was encoded in ASCII. That means that every 8 zeros and ones we bump into represents exactly one character on this table. Okay. So, for example, A in ASCII we saw as a 65 decimal, 41 hex, 101 octal. All right, that's what that value is. All right, those three things mean the same thing. Now, what's interesting here is notice they haven't shown us the binary version of that. So let's go and look at the binary version of that. And I wrote 64 and 65. So if I say 65 binary to octal, I want to convert the number 65 from binary to octal. One of the things that we need to be able to do as network specialists, really all computer scientists, is we need to be able to move between bases conveniently, strongly, let's say. And I'll show you a trick here in a minute, but for right now, we'll start off with the high level thing here. And that has more to do with, as network specialists or any sort of computer science specialists, we are masters at communicating with computers. All right. Now, most of us are fluent in various natural languages: English, Telugu, Urdu, Tamil, whatever it is. Okay. We're fluent in those languages. And we're also very skilled at talking to human beings. We've spent our entire life communicating with other human beings. Now, some of you with degrees in computer science have had some formal background in communicating with computers. All of you have used computers for years, so at some level, you've been communicating with computers, but most of the time you're using power tools to communicate with a computer. You're using like an operating system or another piece of software that, you click a couple things in the software and it does the magic behind the scenes of actually talking to the computer hardware. All right. Well, when we get down to the science, when we get down to computer science and what's actually happening under the hood, we need to understand that translation. How do we talk to computers directly? Because we want to know what are the different ways we can represent data. All right. So if I'm going to convert a binary number to an octal number, what are the things I want to show to you today? Now, I'm sure some of you, well, actually, let's just do an exercise here. Go ahead and take a minute and convert 65 in binary to octal. And don't just do it via Google. I want you to do it by hand. Okay, so take a minute, and I don't expect all of you to know how to do this. I just want to see how many of you do know how to do this. So take a minute, convert 65 from binary, and hold on, I'm not going to octal. I'm going to, I need to drink more coffee today, apparently. 65 decimal to binary. That's what we're doing here. So this is our number 65 representing an uppercase A. I want to get that into its binary format. So take a minute and do it. And when you have your answer, just go ahead and put it in chat. And I understand that not all of you will put an answer in there. So I just want to kind of get a bead on how many of you have this background. And again, it's okay for you not to have this background. I just want to have an understanding of how much detail I need to go into in some of these things to make sure that I don't leave anybody behind. So you don't have to be embarrassed if you don't already know it, because again, I'm assuming that all of you are master's caliber students and will be able to go and learn the stuff that you don't already know. And I will go through how we calculated this in a second, and then I'll also show you a couple of tricks that some of you might not already know. Go ahead.
Sir, can we we need to try with the LCM like LCM method? Are you asking about that?
I want you to convert this number from base 10 to base 2. I want you to show me the zeros and ones version of the number 65.
Hello. Hello.
Yep.
We can use 8421 as the code, and we will be representing the sum with the ones down the order, and which are not in that sum, we will be representing zeros.
Well, correct. But ultimately, all I'm asking you to do right now is to give me the zeros and ones version of, so the base 2 version of the base 10 number. I want to see how many people know how to do that conversion. Okay, we got a couple answers. They're not the same answer, which is interesting. Let's give it another 30 seconds, and then I'll show you how to solve it. All right, so we really have two patterns for converting from one base to another base. All right, we have two patterns for converting from one base to another base. The pattern from going to decimal to binary, or decimal to any base. So decimal to any other base requires that we divide by the target base over and over, recording the remainder until we have a quotient of 0. All right, and I'll show you what this means right now. So we'll start with 65. We'll divide 65 by 2. 65 divided by 2 is a 32. 32 times 2 is 64. So we have a remainder of 1. Now, this number is not a 0 yet, so we're going to divide it by 2 again. 32 divided by 2 gives us a 16. 16 times 2 is 32. So we have a remainder of 0. 16 divided by 2 is 8. 8 times 2 is 16. So we have a remainder of 0. 8 divided by 2 is 4. 4 times 2 is 8. So we have a remainder of 0. 4 times 2, or 4 divided by 2 is 2. 2 times 2 is 4. So we have a remainder of 0. 2 divided by 2, 2 goes into 2 one time. 1 times 2 is 2. We have a remainder of 0. 1 divided by 2. Why are we still going? Because this number is not a 0 yet. How many times does 2 go into 1? It goes into 1 0 times. 0 times 2 is 0. We have a remainder of 1 to get us to a 1. We know we're done when we end up with a 0 here. We read our answer from bottom up, although this is kind of an inconvenient number because it's the same number forwards and backwards. But the first number I'm going to write down is this bottom one. So this is 1 0 0 0 0 0 1. So this is the binary version of the number 65. Okay. And what I want to do here. Oh, this is fine for right now. All right. Let's see, how did we do in our. So a couple people had it right. All right, so any questions on how I just did that conversion? Now, let me just show you something interesting here. So I go back here. 65 in octal was 101. Well, let's see if that's true. So I'll create another slide here. We'll say 65 decimal to octal. Same thing, we're going from decimal to a base. So we're going to divide by that base. So 65 divided by 8 is 8.125. That's an 8. 8 times 8 is a 64. So we have a remainder of 1. 8 divided by 8 is 1. 1 times 8 is 8. Remainder of 0. 1 divided by 8, 8 goes into 1 0 times. 0 times 8 is 0 with a remainder of 1. We read our answer from the bottom up. Again, it's the same way both ways. 1 0 1. Octal. So the decimal number 65 is equal to the octal number 101. Now, what if we go to hexadecimal? Hex is base 16. Same pattern again. 65 divided by 16, we're dividing it by the base. 65 divided by 16 is 4. 4 times 16 is 64 with a remainder of 1. 4 divided by 16. 16 goes into 4 0 times. 0 times 16 is 16. With a remainder of, or 0 times 16 is 0 with a remainder of 4. Then we read our answer from bottom up. So this is a 4 1. 41 in hex. Okay. So is everybody convinced that all 3 of those values are the same value, just in different languages? The language of base 10, the language of base 8, the language of base 16. And hopefully we've seen that we use the identical pattern to go from decimal to octal, as we did to go from decimal to binary, as we did to go from decimal to hex. Now, one extra thing I'm going to throw in there just as a lesson with hexadecimal. Legal values in various bases. So binary, which is base 2, our legal values are 0 and 1, right? We've seen that. Octal, which is base 8, what are the legal values in octal? They would be called the legal octets. Well, here we'll start with something easy. Decimal. We all know decimal, right? When you're making up your decimal numbers, your base 10 numbers, what are the digits that are allowed in that we're allowed to use in all decimal numbers? What digits do we have? Nobody can claim ignorance on this one. You all know the answer to this question. Any number you write in base 10, you're going to be writing in terms of what values, what digits.
Uh, 0.5, no. 0.5 was like point system.
Well, I mean, if I write the any number that you write, so like if you say you're writing an age, okay, any number that you write in base 10, you use the language of numbers, the language of digits. Okay, what are these guys called? These guys are called bits, right?
Yes, bits.
0 or a 1 is a bit. All right. So the language of values that we build binary numbers out of are called bits. The language of values that we build decimal numbers out of are called digits. All right. They're the same. I mean, they mean the same thing. We just have little fancy names for them. But the digit is the language of values that we use to build all decimal numbers. So if you looked at 10 million decimal numbers, 10 million random decimal numbers, they will all be built in terms of which digits? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9, right?
Mm.
That's the language.
Digits, yes.
Okay. The language of decimal is the values 0 through 9. Okay. What's the language of octal? In octal, they're called octets. These are called bits. These are called octets. These are called digits. These are called hextets. So what's the language of octal numbers?
Zero to 8, 7.
Yep. So, and why is this? So I want us to start noticing a pattern, just like we did these conversions up here. And we saw that converting from decimal to any other base followed the same pattern, right? I want us to see the pattern here. So bits are 0 to 1. Why? Base 2 is going to be 0 to the base minus 1. 0 to 1. Base 8 is 0 to the base minus 1. 0 to 7. Decimal is 0 to the base minus 1. 0 to 9. We're seeing the pattern. For hexadecimal, it's going to be 0 to the base minus 1, which is 15. So it's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, now we have problems because if we're building hexadecimal numbers, we can't say 10 because is it 10 or is it a 1 followed by a 0?
Yeah.
It's an A. Then it's a B, C, D,
D.
and F. So an A is our representation for a 10, an 11, a 12, 13, 14, and 15. So an F is 15. So this is 0 to 16 minus 1, 0 to 15. All right. And officially, these guys would be called bits. These guys would be called octets. These guys continue to be called digits. And these guys are called hextets. All right. All right, so far so good. Are we starting to see these patterns? That even though we say the number in decimal or octal or binary, it's all the same value, just said in different languages. All right, so we have different ways as human beings of encoding magnitude, encoding data. Well, yeah, we'll just say encoding magnitude for right now. All right, and the reason I wanted to bring this up is, let's say I wanted to convert 2989 decimal to hex. All right, I very specifically picked this number. All right, again, we're going decimal to some other base. So go ahead and take a minute and try to do this problem. It's the same problem as we did right here. We went from 65 from decimal to hex, so we divided by 16 over and over again, recording the remainder, kept going until we hit 0. So go from 2989 decimal to hexadecimal. So take a minute, do that, and throw your answer out in chat, and then I'll solve it here. Thirty more seconds. Rizwan is saying that you're unable to hear my audio. Can you hear me, everybody?
Yes, I can hear you.
Yes, Michael. I can also hear you now.
All right. Well, we got an answer, and it's the correct answer. So let's go ahead and do this. So we'll say 2989 divided by 16 is 186. So 186 times 16 is 2976. So that's a 13 remainder. 186 divided by 16 is an 11. 11 times 16 is 176. To get to 186 is a remainder of 10. Eleven divided by 16 is 0. 0 times 16 is 0 with a remainder of 11. So now we might be tempted to write this as 111013. Okay, but now is this an 11 or is this a 1 followed by a 1? So that becomes our problem here. So what we do is we translate these guys into their equivalent hextet. An 11 is actually a B, a 10 is actually an A, a 13 is actually a D. Then we read it from bottom up. So that is BAD, bad. All right. So what I want you to appreciate from what we just done is we use the same conversion pattern. We did it from decimal to binary, so that's once, twice, 3 times, 4 times. We use the same identical pattern to move between decimal and 3 different bases. The only thing we change is what we were dividing by. For hexadecimal, we divided by 16. For octal, we divided by 8. For binary, we divided by 2. All right, everybody's good with that? All right, now let's go the other direction, and then we'll come back to this. As I mentioned that there's exactly 2 patterns. So decimal to any other base is 1 pattern. So let me steal this guy. Now, what if we're going from another base to decimal? This is our second pattern. We start at the end of the binary number. That is the ones place. And we work towards the beginning. Multiplying each value by the current place. Each time place is multiplied by the starting base. Let's see, 5 zeros. Okay, so this is the 1s, 2s, 4s, 8s, 16s, 32, 64. So this is the 64s place. This is the 32s place, 16s place, 8s place, 4s, 2s, 1. So when we start at the far right, this is the 1s place. Times 2 is the 2s place. Times 2 is the 4s place. Times 2 is the 8s place. Times 2 is the 16s place. times 2 is the 32's place, times 2 is the 64's place. And then what we do is we multiply and add. So this is 1 times 64 plus 0 times 32 plus 0 times 16 plus 0 times 8 plus 0 times 4 plus 0 times 2 plus 1 times 1. And we add all that together and we get a 65. That's 64 plus 0 plus 0 plus 0 plus 0 plus 0 plus 1. So that is this number in binary converted back to decimal. Similarly, if we go from octal, 101 octal, back to decimal, again, we're going from another base to decimal, so we use that second pattern. That's a 1, 0, 1. That's the 8s or the 1s, the 64. So this is a 64th place. This is the 8th place. This is the 1's place. So the far right is always the 1's place. Times 8 is the 8th place. Times 8 is the 64's place. 1 times 64 plus 0 times 8 plus 1 times 1 equal to a 65. So 101 octal is equal to 65 in decimal, following the identical pattern. .41 hex decimal. It's the 16th place. This is the 1's place. So it's the 1's place times 16 is the 16th place. We have 4 times 16 plus 1 times 1 is equal to 65. 4 times 16 is 64 plus 1 is 65. And then if you want to see it by our other example, BAD hex to decimal. It's a B, that's an A, that's a D. This is the 1s, the 16s, the, what is it, 256? So this is 256. This is the 16's place. This is the 1's place. And remember that BAD is actually an 11, a 10, and a 13.
30.
So this is 11 times 256 plus a 10 times 16 plus a 13 times 1. Copy that real quick. And we're going to see that it's 2989. So there's 2989 is that math. All right. So knowing just those two patterns, you can convert from any base to decimal and from decimal to any base. And I mean any base. It doesn't just have to be bases that we have names for. If I were to say For example, what if I said convert the number 1421 from decimal to base 21? Go ahead and take a minute and do this. Again, we're going from decimal to another base. So we're going to use the first pattern we looked at today, from decimal to another base, where we divide and record the remainder. So go ahead and take a minute, try to solve that problem. We can just throw it into chat once you have it. Got no answers yet. Three more seconds. We got nothing? Killing me. All right. So applying the exact same pattern as we did before, we're going to divide this number by 21 over and over again and record our remainder. 1421 divided by 21. 1421.
67.
67. 67 times 21 is 1407.
07.
Okay, so that is a remainder of 14. 67 divided by 21.
3.
Is this a 3? 3 times 21 is 63
63.
with a remainder of 4. 3 divided by 21 is 0. 0 times 21 is 0 with a remainder of 3.
340.
Now 14 is actually an E.
E.
Okay. 348.
So this is 3, 4, E.
E.
that makes sense?
Yes.
All right. And similarly, well, here, we'll just, oh no, I want you to work for it. I'll give you the fair warning. There's going to be a quiz next class on this exact stuff. So make sure you're studying this. So we'll give you another slide here. So let's do 28 BC. Base 23 to decimal. So convert 28 BC from base 23 to decimal. That's using our second adder. All I'm asking you to do here is to memorize two patterns. Once you know one, you can convert from decimal to any base. Once you know the other, you can convert from a base to decimal, any base to decimal. So take a minute and try to convert this number from base 23 to decimal. We got three answers so far, and they're three different answers. All right, let's go ahead and look at this. That's a 2, an 8, a B, a C. And I'm going to go ahead and rewrite that as 2, 8, 11, 12. And this is the ones place, the 23's place, the 529's place, and the 12,167's place. So this is 12,167. I need to space some more. $529. $23 and 1. So this is 2 times 12,167 plus 8 times 529 plus 11 times 23 plus 12 times 1. And that is 28831. So that's 28,831 is 28 BC in base 23. All right, make some sense?
Yes.
Yes.
All right. All right, so any questions about those two patterns? So in the last, it took us a couple minutes to get started today. So really in the last hour, we've learned 36 languages, right? We can represent numbers now in all the bases between base 1 and base 36 using the entire English alphabet. After you run out of the alphabet, then you have to start coming up with new funky symbols and things like that. The good news is that we typically aren't needing bases larger than that. Let me ask that. What is the advantage of using a large base? So kind of like why might base 21 be better than base 2? What do you think? When would you choose base 21 over base 2? Again, understanding that whatever you write in base 21 that is equivalent to base 2 is the same number. You're just saying it differently using a different language. It's the
Maybe for more security for database.
and more security. I suppose in a certain situation that could be true. You know, you could kind of say that, oh, maybe you're throwing people off because who's going to expect your value to be in base 21? So kind of the idea of security through obscurity. But I would say that's not the answer I'm looking for. I'm looking for more of a mathematical answer. What's the advantage of a larger base over a smaller base?
It has multiple factors.
Multiple factors. That sounds made up. What does that mean? What do you mean by multiple factors?
I mean, the large base number like 12 can have multiple factors when compared to 2.
Well, what do you mean by factors?
It can be divisible by multiple numbers. Like we can get 12 by 6 divides, I mean multiples by 2, and 3 into 4.
But they're still the same number. Just because they're in different bases, they're still the identical number.
Yeah, you're right.
Yeah, we have not changed anything, and that's why I really wanted to emphasize. That's why I made the mention at the beginning of class about because even though those of us in class today maybe have different computer science backgrounds, like some of you, maybe the stuff we did today is, you know, stuff that maybe was a little rusty, right? But you know, stuff you've seen before. Others, this might have been the first time you've seen this crap. Okay, but all of us, especially in this classroom, I mean, as I look down the list, even if I'm just stereotyping off of names, all of you speak at least 2 languages, right? You speak English, and then you speak the language of wherever you came from. And for those of you who are in India, you really probably speak 3 languages. You speak English, the language of wherever you came from, and then Hindi to talk to everybody else. Because the people next right, so like if you're in Hyderabad and you're trying to talk to somebody, was it to the east is Tamil, right? You know, you don't speak the same language as them, so you either have to learn Tamil or you default to Hindi. Or my experience in India is you just speak English because all of you grew up speaking English when you were younger. Yeah, but so in any case, every single one of you in here can relate to the idea of being able to say the same thing in different languages, right? You know, if I ask you to say, how do you say where is the cafeteria? In Tamil or in Urdu or in Telugu or in English, you could, right? You're saying
Yes.
the same thing. You're just using different words to represent it. All right. And that's all we're looking at today is how do we say the same thing in these different languages, these different bases, but use different words. So I'm asking here is what's the advantage of using a large base?
Less memory usage and faster processing.
Okay, so we're moving in the right direction now. Possibly less memory usage depending on what you're doing, but let's kind of put that in human terms. We might say that really big values can be represented in a smaller footprint. Okay, so large values can be represented in a smaller type thing. So when you're using computers, who are the players in human computer interaction? All right, well, the answer is given in the question. So when you have a human being dealing with a computer, we have humans and we have computers. These are the two different, so again, I want you to think about this as like people from different countries talking to each other. Okay, so if I'm a human being and I'm speaking to another human being, we're going to agree upon, so for all of us in here, we're going to pick English as the language we're going to speak, right? Because, you know, I'm the dumb one and that's the only language I know. Even though I said I'm fluent in Telugu and all those other things. I only know the bad words. And I do know all the bad words. So in any case, so we've defaulted to English in here because that's what I speak, right? And most of you grew up learning English for the most part because, you know, there's too many Americans floating around who speak English. So you had to go and learn English and say, look, if we're going to work in that world economy, well, there's too many dumb Americans floating around. We better learn their language because they're not going to learn ours. Just the nature of the beast, right? So I know in India, you start taking English really, really young. I don't know what it is in Saudi Arabia, but I'm guessing it's very similar because most Saudi students, their English is very good. So I'm guessing it's a pretty similar thing where you start learning English at a very young age. All right. But the idea is that you've learned the languages that you need to speak to human beings from different areas. All right. So if we're talking the language of numbers, humans have picked base 10 as their native language. Okay, why have we picked base 10? Why do you think? Why base 10?
Because I'm using digit.
Because you look at your hands. How many fingers you got? You got 10 of them, right? 10 fingers, 10 toes. You know, when you're a little kid, you count on your fingers, right? Okay, so base 10 is very compatible with human beings. For computers, and we'll just finish up here, and then I'll talk about what we're going to be looking at for next class. Okay, for computers, they've picked binary for their native language. But then they also have a couple of other common languages. I'm going to throw Octal in here. Then I'll put some question marks here. I'm going to remind myself to start here for next time. And when we talk about hex, when you deal with computers, and I'm sure some of you have seen this, when do you see hexadecimal numbers with computers? If you're using a computer, many of you said you were programmers, so you've done some programming. When do you see hexadecimal values?
In colors.
That's true. You do see it for colors. And part of that's because our color palette's gotten huge, right? In the early days, we had 8-bit color. So you only had 256 unique colors. Okay, now we have humongous, 24-bit, 32-bit color, things like that. So we need, rather than writing something out in 32 zeros and ones, we can represent it in a smaller footprint using hexadecimal. Okay, so colors is true. Wasn't the answer I was looking for, but that's an accurate answer. Where else do you see hexadecimal in computers? Memory addresses.
Yes.
Okay, and why? Computers have huge amounts of memory. And to address that in binary, it's stuck. I'm going to give myself a slide for next time. We're going to say Y octal, Y hex for memory addresses. And then I'm going to talk about the shortcut for conversion. All right. So next class, we're going to have a quiz during class. We'll do it at the last part of class next time, where I'm going to give you several conversion questions, several numbers that you'll convert between. So it'll be decimal to some other base as well as bases to decimal. And that'll be your in-class quiz that you'll turn in for a grade next class. So your job between now and next class is to make sure you learn those things. And what I'll do here just at the end here, I'll flip through. I will email everybody with this a link to the video for class today. And I'll also give you a link to these slides since not everybody has access to Blackboard yet. I do also want everybody to join our Slack channel. I'll also give you a universal link for that so everybody can join Slack. I use Slack in class. All right, but for right now, your quiz next class will be covering the conversion stuff that we talked about today. Make sense?
Yes.
So between now and next class, make sure you're competent with those things. You can use a calculator, but don't use Google.
Okay.
I'll be upset. I'll be upset. You don't want to upset me. Most of you haven't seen me in person yet, but I'm 6'5", 400 pounds. I'm a big dude. When I was in India, everybody called me Big Show because I guess wrestling is really popular in India, and I'm like I'm like the size of that guy. All right, questions, comments, concerns, bribes. All right, so I will see everybody on Zoom again at 8 a.m. on Wednesday. And look for some email from me between now and then, but you have your marching orders for next class's quiz. Right.
Michael, I have a question.
Sure, go ahead.
How about another course? Are we going with this advanced computer networking, or else we are registering for one more course as well?
Well, this is the only course going on right this second.
Okay.
So the grad courses meet in 8-week chunks. So they're called mini. They're called mini sessions here. So usually, actually, we don't have a course that starts in January.
Oh,
So I'm doing this course for you all. You're biting into my vacation.
oh my God.
All right.
Okay,
Oh.
so usually our class starts. It would start when the semester begins. So I think the next mini term, I think it's March. So I think the next group of classes starts in March, and then the next group of classes starts in June. So it's kind of like every 8 weeks, there's classes. So now, from your guys' perspective, there'll be 2 face-to-face classes in March, and there'll be 2 more face-to-face classes in June. Then we also have several online classes that will be in March as well as June. So they follow the same calendar, but those classes are 100% online. Now you are allowed to take online classes. You just have to make sure that you have, you want to confirm with Robin Kuzu and or any of the folks in the international office, how many credits of face-to-face classes you do need, because I know COVID protocols have changed some of the rules or whatever, but the face-to-face classes exist for our international students, even though you will have domestic students in your classes as well when we're back into normal session, because those our undergrad program has a scholars program where some of our undergrad students are doing a master's and a bachelor's in 4 years. So you'll have some seniors in undergrad starting to take their grad classes, and they'll be in the classroom as well once we're back on campus.
Okay.
But if you go to the registration screen, so here I can show it to you here. So if you go to my.cuw.edu, at least I'll show you how I get to it. There might be a better way for you to get to it. Okay, so once you've logged in, I always go and I pretend like I'm a student. So I click on student, then I scroll down to register for classes. So I pretend like I'm going to register for classes, and then I click browse classes. And I'll go ahead and I'll choose spring as my term, because technically we are in the spring term right now. This is the first mini session of spring, even though typically this is what I think this is mini session A. Well, I don't know what it is, but we typically don't teach a class during this mini session. And then just putting computer science as the subject here, and then hit search. Now I always scroll down, I switch the results per page to 50. So these are all the computer science classes, including the undergrad classes. So you want to get down here to the 500s. All right, so now any class in the 500s that has a meeting time, like this guy right here, this starts on March 7th. This is cybersecurity with Dr. Wall. He's a good guy. So
Yes.
looks like some of you are already signed up for it, but make sure you sign up for that. You'll like Dr. Wall. The jury's still out whether you'll like me. Let's see. This is the class you're in right now, Applied Computer Networking. See, look, only 5 of you are enrolled in this class. We had 14 people in class. So if you're one of the people who's capable of registering right now, I know some of you are waiting for your documentation to come in from the university. So some of you have a legitimate excuse, but if you don't have a legitimate excuse, remember, I'm 6'5", 400 pounds. Big show. So this is the class you're currently in. And then the mobile computer architecture will be starting in March as well. So that's with me. So all of you will probably be taking that. And actually the stuff we're talking about right now, though, that binary stuff, that's going to be very helpful here in that mobile computer architecture class as well. We do assembly language stuff, and we're going to be doing programming stuff in here. One you'll learn pretty quickly. I'm our programming person. So if you ever have a class with me, chances are you're going to be doing some programming in it. But we'll do a lot of coding in class, but whatever. And then also in March is language theory, which I teach. So this class is only if you are in the software engineering concentration do you need the language theory class, which many of you are in the so all of you are MSCS students. Some of you are information systems concentration, some of you are software engineering concentrations. If you're in the software engineering concentration, you'll need this class, language theory. And let's see. Then in May, it looks like May is the next start time. You'll have applied RESTful APIs again with me. That is also in the software engineering concentration. So our 4 face-to-face classes are 525 cybersecurity, which starts in March. The class you're in now. Mobile computer architecture, which starts in March. Language theory, which starts in March. And then applied RESTful APIs, which starts in May. Well, that's 5, but I told you we added this extra section because several of you were able to get your visas for a January start date. In order to make it so that you were legally allowed to be here, we had to give you a class. So again, I'm doing this for you. 3 more weeks of vacation I get, but this.
Thank you for that one.
Thank you.
Appreciation.
But then you'll notice in here that these other 500 classes, so like 510, which is actually starting right now. So there is an online class right now, which is vocational computing. It's like an ethics class with Professor Josh Locklear. So here's the CRN for that, 32385. So you could do an online class right now as well if you wanted to get 2 classes out of the way. But that class does not meet. Notice here where it shows the days. It doesn't meet in person. It doesn't have a normal scheduled meeting time. It's completely online. You do it through Blackboard. There's assignments, there's readings, there's all that stuff. Your interaction with the teacher, he'll grade your stuff. And then you can also ask questions and things like that, but there is not a scheduled meeting time. We also have a user experience class that Josh is also teaching starting right now. That's a CSC540. That's human computer interaction or user experience. Let's see, we have a database administration class that Dr. Wall is teaching right now, again online. System design and configuration. This is in the information systems concentration. That starts in March, online. I have a mobile computer architecture class that's online, even though many of you will be taking it face-to-face starting in March. There's also an online version starting in May. Similarly, there's a language theory. There's an online version of language theory in March, as well as a face-to-face one in March. System administration starting in May. That's in the information systems concentration. There is an advanced networking course that's starting right now. 552, that's online. You could take that, this course and that course. This course is not a prerequisite for that course. They're 2 separate classes. But my advice to you would be, if you have never had networking stuff, that class might be, you might have to teach yourself a lot. But that doesn't mean you can't do it. It's you can take the class, but that's going on right now, fully online. And then RESTful APIs is going on in May as well. Looks like I teach a face-to-face and a online at the same time. So those are your classes, and that's how you can kind of get to them, by going to that browse classes thing and pretend like you are a student looking at the calendar. All right, other questions?
No, Michael.
All right, anybody else? And I think many of you met Blade, right, at the orientation.
Yes.
Yes.
So, so that's Professor Yiming Liao. He did his master's in IT here. And he also did his master's in computer science. He's working on his PhD at Marquette. So him and I remain friends. We've been doing breakfast every Saturday morning for years since he did his MSIT. And then he went off and worked in industry for 3 years, and he was sponsored right away, but missed the lottery. So, you know, had to come back and go to school, but, you know, now he's on his H-1B visa doing his PhD and teaching for us. So you won't have him for any of your classes because all your teachers have to be PhDs for the master's degree, but he's an excellent resource. He's been around for a while, knows all the ins and outs of the you know, the student visa process, things like that. Let's see. So he would be somebody to get to know, to ask questions about that. If you are looking for, I know some of you have already talked to me about this, but and this is for all of you, but I would say specifically the Indian students. I'm pretty close with some of our former students from India. One of them, his name is Shiva Krishna Bujanuri, and he's married to an American lady now, but he is pretty close with several of the Indian students and kind of keeps his finger on that pulse. So he kind of knows about who's looking for roommates, housing, things like that. So if you are looking for that type of thing and looking for a place in the Milwaukee area, let me know and I can connect you with him, and he might be able to connect you with the right people. But in any case, he also obviously knows the ins and outs of the whole process, and, you know, is quite aware of some of the hardships that the immigration process makes you go through and that kind of stuff. So if you are interested, I can certainly introduce you to him. Okay. Any other questions before we call it quits? All right, I will. Oh, let's see. There was one chat. Oh, just no. Okay. So I will see everybody at 8 a.m. on Wednesday.
Yeah.
Have a good one.
Thank you.
Bye-bye.
Have a good
Have
one.
a good day, sir.